Hey everyone, in this video, we'll solve LeetCode problem 752. We'll first understand the problem, then build the solution step by step. As we go, we'll talk about the thought process, why BFS makes sense here, and how to model the log states correctly. I'll also point out a few common mistakes so we can avoid them. By the end of this video, um, I hope you'll be comfortable with not just solving this problem, but how to approach similar kind of problems. Alright, let's dive in and solve this question. Alright, let's first understand the question. We are given a log with 4 circular wheels, right? And each wheel has 10 slots from 0 to 9. The wheels can rotate freely and wrap around. That means we can go from 9 to 0 and 0 to 9. It won't get stuck when we reach 0. That means it's not like it won't go back. It will go back to 9. And similarly, from 9 we can go forward but we'll reach 0, right? The lock initially starts at 0, 0, 0. All four numbers are set to 0. A string representing the state of the four wheels, correct? You are given a list of dead ends, meaning if the lock displays any of these codes, the wheels of the lock will stop turning and you will be unable to open it. That means dead ends will be an array of numbers that or a array of combination of lock, that if we reach that state of the lock, we can't proceed further from that state, right? Then we'll be given a target representing the value of the wheels that will unlock the lock, return the minimum number of turns required to open the lock, or -1 if it is impossible, right? So we'll start from 0, 0, 0 and we will try to reach our target without hitting any of the dead ends. We can also move from one state to another by turning only one of the wheels only one time. That means, say our state is 0, 1, 2, 3, right? And we want to turn this wheel. This wheel, if you want to turn, it will either become 0, 1, 1, 3 or 0, 1, 3, 3, right? We cannot make 0, 1, 5, 3 from this state. That is not possible. 2 cannot become 5 in just one single turn, right? That means every wheel or every number can either go up by 1, +1, or -1, right? And of course, if we want to turn 0 with a -1, we will reach 9. And similarly, if you want to turn 9 with a +1, we will reach 0. So in the question, what are we given? We are given a initial state, we are given a target state, we are given a set of forbidden state, and every move is a fixed. We can only move +1 or -1. So these four things should make it sound like a graph question, right? Every state is a node. This is the target node and these are the forbidden nodes, right? And this move of +1 and -1 is an edge, right? So that means we just need to traverse the graph from initial to the target without hitting any of the forbidden nodes, and we have to find the minimum number of moves. So this minimum number of moves should mean BFS, right? So that's why BFS fits in this question, right? Now, as we have seen that BFS makes sense in this question, let's try implementing the BFS and we'll explain each block of the code as we write it. So the first thing that we definitely need to ensure is that we never reach the dead ends, right? And for that, since it is a string, we need to convert it into a map. It's called map the deads, map of string to bool, right? Now we'll iterate over the dead ends and add those dead ends into the deads map, right? So for underscore comma d, okay. Now we need to make sure that the initial state, which is 4 zeros, is not in the dead ends array, right? Because if it is, we can't even start processing or start the process of finding the target, right? So if deaths of 0 it is true, then we return -1 because it is impossible to find the target since the initial state only is in the deaths map, right? Then since we will be implementing a BFS, we need to append a state to the queue. That's how it works, right? So we need to model the state of the lock first, right? So what we need to store in the queue is a type of pair which will have state. This will be the lock state that we are currently in, and level int, and this will be the level value will be the number of moves we have made to reach this particular state, right? And if this state is the target itself, then we'll return this level. So that's the logic. If we reach the target state, will return the level for that state, right? Now q equal to array of pair, and the first pair the q will have is 0, and the number of moves we have made to reach 0 is 0 because that's the initial state, right? We also need a visited map, make a map of string to bool, right? And we'll say visited of 0 is true, right? So that we don't come back to this state again. We'll start from the initial state. We don't want to come back to initial state again, right? Now we'll append we'll start processing the queue. So for length of queue greater than 0, we'll take the first element current q of 0, and q becomes, we'll slice the queue, right? Now state comma level equal to current dot state current dot level. As we discussed earlier, if this current state is the target state itself, then we return the current level, right? Then say we have this state 0 0 0 0, right? When we try to process this state, each number will be changed, right? So this 0 from 0 can become 1 till 9. Same with this, same with this, and same with this. Everything can from 1 to 9, right? It can become 1 till 9. That means we need to process each number separately. We need to iterate over the state as well, and for that we have to convert the string into an array of characters, right? So this 0 0 0 0 will then become an array of 0 0 0 0, an array of characters. So let's do that. That will be characters equal to array of rune of state. So in Golang, there are no characters type, we have a rune type, right? Now we'll iterate over this character. So for I 0, I less than 4, and I plus plus. Now why 4? Because every state will have 4 uh, numbers or characters, right? Now the current character that we are trying to iterate is digit equal to characters of I, right? Now we need to convert this into an int, because as I said, the 0 can become 1 and 9. For that, this 0 needs to be an int. So that plus 1 gives this, minus 1 gives 9. How will we do that? We'll see. But plus 1 should give us 1, right? So that is possible only if 0 is an int. So we need to convert that. And how will we do that? We'll do it like this. How does this help us? Let's see, or how it works. So let's say we have a character of 5, right? We have a character of 5 and we want to convert it into an int of 5, right? So 0, 1 till 5, right? So since they are characters, if we convert them to directly to numbers, 0, the ASCII code of 0 will be 48, this will be 49, and so on till 5, which will be what? 48, 49, 50, 51, 52, 53, right? So we want to have 5, convert 5 into an int 5. What we do, this 5, character 5 minus character 0, that gives us 48. So 53 minus 48, and that gives us 5. So that's why when we want to convert from character to an int, we do subtraction, right? So now we have the digit in an integer format. Now what we can do is, we need to make the move, right? And the only moves that we can make per character is either go up or go down. That means plus 1 or minus 1, right? So we'll say for underscore comma move, the only moves we can make is minus 1 and plus 1, right? Now here we also need to handle the move from 0 to 9, right? If we do 0 minus 1, it should give us 9. How to do that? So we'll write something like 0 plus the move that we are trying to make, which is essentially this only, but we'll add an extra 10 to it. So that means 0 minus 1 plus 10 minus 1 plus 10, and that gives us 9, right? But this works here, but for 9, so 9 should move to 0. 9 should become 0 when added 1, right? So 9, so the formula was 9 plus move plus 10. Here it breaks 9 plus 1 plus 10. That would give us 10 plus 10, right? So that would break here. So what will we do? This becomes 20. We don't want 20. We want 0, right? We want 0. So for this, after doing this, we'll add a modulo of 10, right? Modulo of 10. So 20 modulo 10 gives us 0, right? And here also that will work. If we do modulo 10, we got 9, right? So 9 modulo 10 gives us 9 only. So it works in both the cases. So that is the formula: the digit plus the move plus 10 and then modulo 10, right? So let's do this. So that will give us the new digit, which will be digit plus the move plus 10 with a modulo of 10, right? Now we have the new digit. Now what we need to do is, this new digit is in the form of an int. we again need to convert it into an character, right? How do we do that? So this will be characters of I equal to, because this new digit is for ith character, right? So it will replace the ith character only. So this new digit will come in place of characters of I. So characters of I now becomes a rune type and new digit plus 0, right? I think you have understood why plus here, because say we have 5 as an int and we want to convert into a character of 5. So what we do, 5 plus character of 0, that gives us 5 plus 48, that gives us 53. And if we convert it into a rune format, character of 53 now becomes 5, right? So that's the maths behind it. Now we want the next to be string of characters, right? So this next represents the next lock state, right? We have replaced the characters of I with the new number, that means our move either +1 or -1, and then we have converted into a string representing the next lock that we got, lock state that we got, right? So now we have to check if not deads of next, that means the next state that we got should not be in the deads map, and it should also not be visited, right? Then we mark it as visited and we append to the queue. So queue append queue comma, we are appending a pair type. This is the state and the level will be level plus 1, because we were in the current level, we have made a move, so the level has increased by one move, so level plus 1, right? Now this is an important step. Here we changed the characters of I, right? So what we did was, say the state was something like 1 2 3 4, right? And we processed this state, so it either became 1 1 3 4 or it either became 1 3 3 4, right? Either it went up or it went down, one move down, right? Then we want to process this. Will we process it here? No, we want to process it as 1 2 3 4, then it becomes 1 2 4 4 or 1 2 2 4, right? So this 2 should be in the original state when we work on this state, but it was changed earlier. So now we have to revert that change back to 2 before we start processing this number, right? So that's why in this step we make characters of I equal to the original digit, which is this one, right? Rune of digit plus a 0, and in the end we return -1. If after doing all these things we could not reach this statement and return a level, that means we cannot reach the target, and hence we return a -1. So let's try running this. Okay, something's wrong here. Oh, okay, I forgot the range keyword here, and it seems to be working. Let's try submitting it, and it is accepted. And that's it. We have successfully solved LeetCode 752. We walked through the problem, modeled it as a graph, and used BFS to guarantee the minimum number of moves. More importantly, we focus on the thought process, how to recognize when BFS is the right tool, and how to manage states and visited tracking properly. If you found this video helpful, feel free to like the video, subscribe, and let me know in the comments which problem you'd like us to solve together next. Thanks for watching, and I'll see you in the next one.